Okay. So today we start from this slide presentation. From last week, we have done all the lesson up until the direct net touch, and as well as two exercise. And these two exercises coming from the book, so you can look for more exercise in the book. And also today's session, we also work on some exercise from the book as well. So we continue from this. Actually, I already explained about what a kite block, right? In the kite architecture, when we talk about how it map between main memory and the kite block, there is something in the middle that called the kite block, which is have the same size between cache and main memory. Just remember that in one block, it contains more data, and in the data inside, it based on the memory address type. Because normally we have a word addressable and a byte addressable. So when you see the memory is organized as word addressable, it means that each word in main memory have one address. But if they say it is a byte addressable, it means that one byte has one address. Anyway, the block is the combination of the word or byte. In here, for the example, we have 4 byte direct map cache and a block size equal 1 byte. Actually, I talk about this previous exercise here. Like we talked about before, here the kite block it contains 16 words. So if you see the word here, meaning that the word the main memory is word addressable. If they say something like 2 power 32 byte, so you can assume that the main memory is byte addressable. Okay. And normally, in each exercise, they always explain or tell you that what is the size of the block. Okay. And if we are talking about the direct map cache, like we have done in the previous session, each block of main memory have a exact location in the cache. Okay. So when we map data between main memory and cache, we are not mapping with the data one by one, but we group them together into block, and then we map the block between main memory and the cache. Okay. And in here, if we want to take advantage of the spatial locality, I hope you still remember it. We are talking about locality or reference. There are two types of locality or reference. One is temporal locality, and this one is talking about the spatial locality. Spatial locality meaning that any data that maybe something that the data that around the target data is tend to be accessed again by CPU. So they call spatial locality. So to take advantage of spatial locality, we can increase the block size. We can increase the block size so that because we assume that all the data around the target data are going to access later. Okay. And in here, we just some example about the architecture of the cache. Like you see last time, here is the memory address, which has 32-bit address. Just an example. And from 0 to 9, actually, this for 10-bit. From 0 to 9, it contains the cache index, and the byte select. Byte select here refers to the offset that you have seen last term. You call it Y select, or you call it offset, or maybe you call it word select, because like I told you before, if it is the byte addressable, it called each byte has one address, and if it's the word addressable, each word have one address. So here, well, you see the byte select, it meaning that they are assume that it is the byte addressable. Okay. So from 0 to 9 is for the kite index and the byte select, and from 9 to 31 is for the kite take. Okay, and based on the kite index here, you can find the block that the data that you want to map. Please, it is just some representation, and you have already seen it in the last exercise. Okay, so here about the block size trade-off. Trade-off here refer to kind of the exchange between benefit and the disadvantage, like we see in the previous slide presentation. If we increase the size of the block, it means that we are taking the advantage of spatial locality, but it's not always provide you the advantage. It also provide you the disadvantage. Okay, here. And the like block size mean like a miss penalty. When we talk about miss penalty here, mean that if you cannot find the data you want to find inside the cache, you are required to copy the entire block from main memory into cache, right? So if the cache block is too big, you need to spend more time to copy the content from the main memory into cache. That is about the point here. If you increase the block size, it means also we have like a miss penalty about the time that you take. And also, if the block size is too big to the cache size, we talk about the comparison between the cache size, total cache size, and the block size. So if the block size is too big comparing to the cache size, so misread will go up. Okay. And here is the average access time equal to hit time multiplied with 1 minus misread plus miss penalty multiply misread. Okay. This penalty here refers to the time that you need to spend to find the data in main memory, and also to the time that you need to copy from memory to cache. So in the exercise, you will find some exercise asking you to find the average access time. Okay. Here, some diagram that you can refer to. Miss penalty is the increase axis, and block size is the y-axis. Okay, you see the block size increase, the miss penalty is also increase. And here, the block size increase. You can explore more spatial locality. So it helps you work block. So it compromises the temporal locality. So need to be balanced. If you take it too big, you need to compromise about the temporal locality. Okay. Do you remember about temporal locality? If it is accessed now, it tends to access again in the future. Okay. So we have another we call it the mapping scheme. What you have seen in the previous session, we talked about direct map cache, and here another option that we can use, call it two-way set associative, and normally you can call it n-way because it can be two-way, it can be four-way, it can be eight-way. Okay, so the number of way here refers to the number of blocker set. Inside this mapping scheme, we group block together into into set. Okay, you remember about the block last time, right? Block is the combination of byte or word, but in here, when we are talking about set associative catch, meaning that there are another group which combine the block together. One set can have multiple blocks, and normally it's at least 2 blocks per set. So if you see the two-way set associative like this, you can tell that in this structure, one set has 2 blocks. If you see that it's called 4-way set associative, meaning that one set has 4 blocks. Okay. So here is the set. See the dash rectangular here. Okay, this dash rectangular here refer to set, and this section refer to one kite block. This one is refer to another kite block. Okay. So it is similar to the direct map catch, but it takes advantage of associative memory. So when we are using the set associative catch, we do the associative search first to find the set that you want to find, and after that you apply the direct map concept inside that set to find your selected data. Inside the set associative catch, actually in this slide we don't have the detail, so I will show you the ebook. It has a complete explanation about set associative. You can find that detail inside the ebook. Let me find it for you. Where is it? The ebook also inside Microsoft Teams, so you can find it as well. So go into this chapter 6. Not here. In this chapter, you can find the kite mapping scheme here about the locality of reference that I told you before. And here we talk about kite memory. This about kite mapping scheme, and we also cover the direct map kite here. Okay, this is the block mapping, and then we have the set associative, which is here. Okay, set associative kite. There are another one in the ebook that they explain it first, which is fully associative kite. Actually, fully associative kite is very simple because when we are talking about fully associative kite, meaning that this kite depend a lot on the hardware. The hardware, if you want to implement fully associative kite, you need to make sure that your kite has associative memory. It's built of associative memory. And associative memory is a kind of memory that allow you to do a parallel search. You can do a parallel search, meaning that you can search multiple data at the same time. So in associative memory, the structure of the data of the main memory address is grouped into 2 sections only. Remember, in the direct map kite, we group it into 3 sections: the tag, the block, and the board. But here, with fully associative kite, we group into 2 sections: tag and board only. So when we want to search the data, we search in parallel by tag here, and when we found it, we need to just look at the offset, and that's it. This is about fully associative. Okay, and the set associative, like I showed in the slide presentation, is the combination of fully associative and the direct map. When we do set associative, it's grouped into set, and in each set there are multiple blocks. Okay, this diagram and this diagram is the same. Just that it's more complex, showing you how they do some search, some diagram here. But then here it's more simple, but the same thing. So here in the example, you see a 4 set 0, set 1, set 2, and set 3. And in each set, there are 2 blocks. Here refer to one block, here another block. See? So this similar to the direct map, right? With this is the combination between a fully associative and the set associative. Okay, so in set associative, we group into 3 sections: the tag, the set, the word. So instead of block here, we use set instead. All right, so let's work on some example to explain how the set associative and the fully associative work. So if you scroll down to find some exercise, we have here, we have done some exercise related to 1 and 2. 1 and 2 here. And exercise 3, exercise 4, exercise 5, 6, 7. They are all about the fully associative and set associative. Okay. Okay, I think we can pick some exercise to do it. We don't need to do everything, just a few only. This one already for the 3 here, not yet, but I don't think that is, we don't need to do it. It's quite similar. Okay, let's just do this number 3 because it's about the fully associative. I already have some here, but don't need to care about it. Let's just do some exercise. We'll use the draw.io like last time. Okay. So the question in the exercise 3 is similar to 1 and 2. The difference is we are using fully associative instead of the direct map here. Okay. Let's make it smaller. Okay, like this. And then we should zoom in. All right, exercise number 3. We are using the fully associative here. So let's just draw some cache and some main memory. Okay. Normally cache is smaller than memory, so we just make some here's cache and this one is main memory. Okay. And then inside our what is it? We have 2 power 16 volt inside the main memory. So here, in our main memory, we have 2 power 16 volt. Okay. So when you see here, we call it word because it is a word addressable. Each word has one address. And then the kite has 16 blocks in here. Our kite has 16 blocks. Made a bit smaller. Okay. So it should be block 0. It should be block 1. It should be block 2. And this should be block 63. Okay, because we have 16 for block here. Okay, so here just blah blah blah. Okay, and then each block contains 32 words. Okay, here we have 32 words. So this is the word number 0. Here is the word number 1. Here is the word number 2. And here is the word number 31. Okay. So this diagram is just taken from this question instruction. And then the question A is how many blocks of main memory are there? So just like what we have done in exercise 1 and 2, question A, simple, just by divide the total word here with the total word inside one block to find the number of total block in main memory here, right? So the question A here, simple, I will do it for you. How many block are there in memory? Okay, so the answer is we need to take 2 power 16 and divide by 32, right? Because in memory there are 2 power 16 words. Let's put it like this, 16 words. And in one block there are 32 blocks, right? And because the size of block in kind is equal to the size of block in memory, so we can divide like this. And the answer is 2 power 11 block. All right, because 32 is equal to 2 power 5. Okay, so the answer for question A is simple, like we have done in 1 and 2. But what is different is here, the question B. So question B is about the format of main memory. Which is the fully associative cache. Okay. So the format of fully associative cache, when you look into this here, the last slide here, there are only 2 sections. One is the byte select, and the second section is the take. Okay? So comparing to the other two mapping scheme, it is the most simple. So what you need to find is the size of your main memory address and the size of the byte select of the offset. Just like this. This one is you can call it byte select. You can call it offset, or you can call it word select, whatever you want to call. There are many names that you can use. Okay, and whatever the name you call, how to find it is the same thing. The offset or the byte select here refer to the number, the amount of bit that you need to identify each word or each byte inside one block, right? And you see here in one block we have 32 words, meaning that we need 5 bits to encode each word inside one block, right? Tell me if you still cannot figure out how to find it. So we need 5 bits here because we have 32 words inside one block. And then the remaining here, the catch tag here, is the result of the total amount of bit in main memory address minus the offset here. Okay, so to find the tag here, catch tag here, first you need to find how many bits require to identify a word inside one main memory here, right? By the instruction, we have 2 power 16 words. So we need 16 bits to encode or to identify all the words inside the main memory. All right. So here the total is 16 bits like this. So we need 11 bits for the take. Okay. Yeah, take. So question B is just like this. Okay. And then the question C, the self with the question 1 and 2 here, the same thing, right? But we want to find the address FAC9. And the address FAC9 here, you don't need to convert to binary like you had done in the previous exercise, because we are using the fully associative. And when we talk about fully associative, you don't require to have exact location. The block can be anywhere. Your data can be anywhere, can be in any block of the type. That's why the answer here is anywhere, right? So if they ask which type block, the answer is anywhere. But if they want to figure out exactly the location, the answer is in any block, but at the offset of. Okay? So if they want to see the offset, in that case, you need to convert this FAC9 to binary and keep the last 5 bits to locate your desired word inside the block. Got it? So here the question is just about type block, so the answer is anywhere. Okay, and the answer is okay. Any question? This one is exercise number 3. Put this side here. Okay, I will copy this and that's in here. Okay. So this exercise is okay, it's similar, just about fully associative. Let's pick another exercise about set associative, like this exercise number 6. Okay. So in exercise number 6, we have two-way set associative this time. And inside, we have 4 sets. A two-way set associative kind consists of 4 sets, and main memory contains 2K blocks of 8 vertices. Okay. So let's copy this and place it here. Okay, so this one is exercise number 6. And here we have a two-way set associative, and then in we have 4 sets, and in each set wait, we have 4 sets. Let's change this. I call it because it is a two-way set associative, and we have 4 sets. That means we have 8 blocks in total. So I call this number 8. Okay, because we have 8 blocks. Remember, two-way set associative refer to one set has 2 blocks. If it is called four-way set associative, you will have 4 blocks in one set. So because we have two-way set associative, and then there are 4 sets, so in total we have 8 blocks. All right. And in each block we have 8 words. Okay, so this one should be number 7. Okay, and then 2 of these equal to 1 set, so I will use another color. Okay, this is for 1 set, and let's copy this one to make it another block, and this 2 block is another set. Okay. Okay, I hope you can understand like this. Make it bigger. right? And so this is set. Okay. And this is set number 1. Okay. And we have four set. We have 4 set in total. Okay. And then main memory contain 2K block. So coming here, instead of telling about how many words you have, it's a 2K block. Okay, so and the question A, so the main memory address format that allow us to map address from main memory to cache. Be sure to include the field as well as their size. So the question here is the same as question here, question B here, the same thing. All right. It's just that now we are using the set associative instead of direct map or fully associative. So coming here, make it bigger. Question A, the same is main memory address given by 2 set associative. Okay. And can remove this, remove this, remove this. The format is different because we are using set associative cache instead of have 2 sections, which is take an offset like we have done in the fully associative. We have 3 sections now. The first section is still the take. Okay, it's still the take. But the second section is the set. Here in the middle is the set. And the last one is still the offset or by select. Okay. So here, to find this format, first we need to find the total bit of the main memory address first. And to find that, we need to see how many words that our main memory address can contain. And from the instruction, you find that main memory address contains 2K blocks. And then from this, you see that one block contains 8 words, right? So in total, you can have 2K multiplied by 8. Good. Okay. Because we have 2K block and each block have 8 words, right? So to find the total word inside our main memory address, main memory, you can just use 2K multiplied with the 8, right? So in total, it equal to 2 power 13, right? Because 1K, oh wait, not 13. 1K is equal to 2 power 10, and 2K is equal to 2 power 11, and 8 equal to 2 power 3. So this should be 2 power 14 words. Okay. So in total, we need 14 bits here to encode all the words inside the main memory. Okay. And then to find the offset, we need to know how many words can be stored inside one block. And you see that we can store 8 words, right? So here is 3 bits. Okay. And then here is the number of bits to identify the set, to identify the set. How many sets do we have now? We have 4 sets, right? So we need 2 bits to identify each set. Okay. As if from the instruction, they say that there are 4 sets. And the number of bits here refers to the number of bits required to identify all the sets. Okay, so we need 2 bits. So the tag here is the remaining, which is 7 bits. No 7 bits, but 9 bits. That's what's coming from. So we need 9 bits here. Okay. Big question. No. So question B, the same. We just change some number. And question B, wait, we compute the hit ratio of for a program that looks 3 times from location 8 to location number 51. In main memory, you may leave the hit ratio in terms of a fraction. Okay, so do you know how to find this? What if the hit ratio, remember? The hit ratio refers to the percentage of that the CPU can find data inside the cache. Okay, so for question B, we are looking for the percentage that the CPU can find the data inside the cache. Okay, so I need to change this. In the same button, please not see here. Find the ledger. CPU access. What? Access 3 times. Look 3 times from location 8 to 51. When they talk about location here, it refers to the address of the main memory. Okay, address A and to address 51. Okay. So how do we find the ratio here? Any idea? Okay, so to have a better understanding, I think we should draw in more detail. Make it bigger. So imagine this is our main memory. And it has two sections, which is the address, and another one, which is the data. So here is the address row.
Sorry,
Address
teacher.
one. Yes.
Nhưng mà sẽ do sân ổ B nữa.
No, nhưng gì chỉ biết sắc này nữa. Sầm no B. Cái trong gì tha present bar CPU thưa ca request data. Thì trong đó nằm bởi CPU thưa ca request data vitamin address nằm chẳng vitamin memory address. Ok. Trong bài vitamin memory address. Chứ không cả đây sầm no B bỏ dương chặt tộc tha CPU thưa ca request data. Pi address pi 8 លេខ 9 លេខ 10 លេខ 11 រហូតដល់លេខ 51 អូខេហើយបន្ទាប់ពី 51 មកវាវិលដើរមកវិញគឺអត់តែលេខ 8 ម្ដងទៀតរហូតដល់ 51 ម្ដងទៀតហើយចុងក្រោយវាធ្វើ request លេខ 8 ដល់ 51 ម្ដងទៀតដោយសារតែវាធ្វើ loop 3 ដងនេះធ្វើ loop 3ដងអូខេតោះណត់អញ្ចឹងមានថា CPU ធ្វើការ request ពី 851 ហើយ 851 ម្ដងទៀតហើយ 851 ម្ដងទៀត 3 ដងអញ្ចឹងគេចង់ដឹងថាតើនៅពេលណាដែល CPU ធ្វើការ request 3 ដងអញ្ចឹង 8 ទៅ 51 ហ្នឹងតើ hit ratio វាប្រមាណ hit ratio ចង់សំដៅថាតើក្នុងចំណោម request ទាំងអស់តើ CPU អាចរកឃើញ data ដែល CPU ចង់បានប្រមាណដងចំណោមទាំងអស់ហ្នឹងតោះណា851នេះគឺជា address របស់ data ដែលចង់បានណាហើយអានេះគឺក្នុងគោលដៅតោះណា
address នៅក្នុង main memory មែនទេ
បាទ address ក្នុង main memory និយាយទៅក្នុងមេរៀនរបស់យើងឥឡូវហ្នឹងមានតែ main memory មួយទេដែលមាន address តោះណាខាច់អត់មាន address unique ខ្លួនវាទេ address របស់ខាច់គឺបានមកពី main memory address ដដែលទេអញ្ចឹងក្នុងមេរៀនរបស់យើងមកដល់ឥឡូវណាគឺមានតែ main memory address ទេដែលមាន address តោះមានតែ main memory ទេដែលមាន address អញ្ចឹងកុំច្រឡំអានោះ address របស់ខាច់អានេះ address របស់អីផ្សេងមែនទេអញ្ចឹង address គឺស្ថា address របស់ main memory ទាំងអស់
Thank you, teacher.
So let's keep going. So here, let's just assume from here 8, 9, something like this. This, and here address 51, all right? Okay. So here we have how many address in total? Let's see. We have 2 power 14 volt, right? So here it should be from 0, right? 0. And let's say here like this should be 2 power 16 minus 1, right? Because we start from 0. Okay. And the question here is the CPU will be making requests from 8 to 59, and it looks 3 times like this. Okay. It looks 3 times. Okay, from 8 to 51. All right, from 8 to 51. And so for the question, to find the hit ratio, here, you need to know the total amount of requests. How many total requests are there? 8 to 51. How many requests? I think it's 132. Okay, you can count it. 8 to 51 and multiply by 3. In total, there are 132 requests. Okay, and what is hard is here. How many times that the CPU requests and it can find in data? There's something that is hard to figure out. Okay, so for now, what we need to do is to find this number. Okay, so let's draw another one for catch like this. Our catch has 8 blocks, and we have 4 sets, and each block have 8 votes. Okay, that make it bigger here. So we have 4 sets, right? So let's make it set 0. We have this one is set 0. This one is set number 1, set number 2, and set number 3. Okay. Set 0. We need to draw it more careful, this one, because if not, it's hard to understand what's going on. Set 1, and this should be set 2. It should be set 3. Okay, and then in each set, there are 2 blocks. Okay, because we are talking about two-way set associative. So in each set, there are 2 blocks. I draw it like this because it's the same like in this diagram. See, they draw it like this. Okay, so it just make it similar to our lesson. So this is block 0, this is block 1 in set 0. And I need to copy like this because each set have their own block. This like this, all right? And here is the block 0. And that is next one is the block 1. Okay, block 0, block 1, block 0, block 1, block 0, block 1. Okay, because set have 2 blocks. And also in each block there are 8 votes. Okay, so let's draw some more. sure if this is big enough. 2. Three. Let's we are missing 2 more. It's a bit too small here. So what is it's confusing. Vì 4 vòng mối. Right. Okay. Lục chạy hình. Okay. Vì 4 vòng mối vòng với. Draw like vì cô chọn bạn một. Ok. Vì mà tiếp lục bạn off đi mở cả. Ok, anh cũng gọi tiếp đã phù hợp xến. Okay. Yes, it's a bit complicated, but to make sure you understand about the exercise, spend some time, make this. Okay, so this is for block 0. This for block 1 in set 0. This for block 0 in set 1 is for block 1 in set 2. Okay. Let me know if you cannot catch up with me. Okay, like this. So when we talk about offset, here should be the offset 0. Okay, this one is the offset 0. It's 1, it's 2, 3, 4, 5, 6, 7. Okay, and here because it's located in another block, we have to reset it to 0 again. Okay, like this. and the same all for all inside here. So this one, this one is referred to one word inside. All right. Okay, so here our question. The CPU are making the request from 8 to 51. And in the beginning, you need to assume that inside our cache there is nothing at all. So when you are accessing, when a CPU making the request to address number 8, we are sure that the number 8 is not exists inside our cache, right? Because we assume that cache contain nothing. All right? Because cache contain nothing, we are sure that address number 8 is not inside our cache. So 8 is missed. Right? Okay. Address 8 is missed. Okay. And then based on what we have learned so far, when the data cannot be found inside the cache, it needs to copy the data from the main memory and store it back to the cache. We do like this because we assume that the data around it or the data itself are going to access again in the near future. It's based on the spatial locality and the temporal locality from our lesson previously. Okay, so when we are accessing address number 8 and it's missed, so it needs to copy the entire block from the main memory and store it into our cache, right? So when we copy the entire block with the data address 8 located. So when we copy from address 9 to address 15. Okay. Like this, done. Actually, it's not just 9, but 8 as well. Okay. And why 8 to 15? Because inside of block it contains 8 words, remember? In our block, there are 8 words inside, right? So when we copy the entire block, and the address 8 is kept inside the block which contain address 8 to address 15. Okay? So we copy the 8 to 15 to the cache. And here is the question. Here the question is where? Okay? Question here. Because we need to know where the data should be stored inside our cache here. Should it store here? It's stored here. It should store here. Okay. So can you tell me when we copy this data, where do we store it inside here? Okay, I give you maybe 5 minutes to think about it. Do you understand? ខ្ញុំនិយាយជាខ្មែរម្ដង ចឹងនៅពេលណាដែលយើង access address លេខ 8 អូខេប្រធានណាយើង access លេខ 8 ចឹងលេខ 8 ច្បាស់ណាស់ដឹងថា miss ហើយដោយសារតា cache របស់យើងគឺតែទេស្អាត assume ដំបូង assumption ណាដំបូងផុតគឺ cache របស់យើងអត់មានអីទេចឹងច្បាស់ណាស់ 8 ដឹងតែ miss ហើយចឹងនៅពេលណាដែល 8 miss best ទៅលើ locality temporal locality ហើយនិង spatial locality គឺយើង copy data ទាំងអស់នៅក្នុង block ទាំង 8 នឹងស្ថិតនៅចូលមកក្នុង cache ហើយដោយសារតែអត្តេ8ហ្នឹងវាស្ថិតនៅក្នុង block រួមគ្នាជាមួយនឹង data ត្រទី9ដល់15អញ្ចឹងយើង copy មកដុំហ្នឹងមកតោះណា ពេល copy មិន copy តែលេខ8ទាំងមួយ copy ទាំងអស់ក្នុង block មួយហ្នឹងណាមកអញ្ចឹងយើងត្រូវ copy block ទាំងមូលចូលក្នុងខាច់នេះប៉ុន្តែសំណួរឥឡូវយើងសួរថា copy ចូលមកមែនតែ copy ដាក់កន្លែងណាគិតតិចមើល copy ដាក់កន្លែងណាតែលេខនេះកន្លែងនេះកន្លែងនេះកន្លែងនេះគិតមើលមិនទៅគិតឃើញអត់ copy ចូល set តិចបានเอาមើល set សិនណាមានយ៉ាងណាគិតអត់ណាសុកហេងហេលសុកហេងនៅអត់ហើយអត់នៅគួរមកអត់វត្តមានមិនចឹងសុកហៃ
បានលោកគ្រូបាន
ហ្នឹងហើយ copy ចូលទៅក្នុង set មួយណាហើយយើងសួរថា set មិនសួរ block សួរអីសួរ set មួយណានេះបើហៅចម្លើយមិនឃើញប្រាប់របៀបដែលគិតថាគួររកតាមណាក៏បានដែរមិនដើម្បីរក set មិនឃើញនេះយើងប្រហើបបន្តិចយើងមើលលើនេះហើយ
បានលោកគ្រូកំពុងមើលលោកគ្រូអត់សូវយល់
ឥឡូវបាត់សូវយល់នៅហ្នឹងអីចឹងកុំអត់បាត់អត់ចាំបាច់ញឹកទៅវិញទេហៅមួយខ្ញុំចឹងអូខេចឹងអត់បាត់
ចាមិនអាលម៉ាត់ A 14 bit ដល់ពេល B 16 bit ចឹង
16វិញណា14ដាក់
ប៉ុន្តែ B ដូចដាក់16ចា
B 16ពេលណា16
ចាំ2 second 16ចា
អូយខ្ញុំសរសេរ2 second 16លំហាត់មុនទេ12 second 16នេះហើយលំហាត់ផ្សេងលំហាត់ទី3អានេះយើងធ្វើដល់លំហាត់ទី6ដល់ទី6របស់យើងគឺទៅ12 second 14ដែរ
ប៉ុន្តែវាឈើដាក់កន្លែង2ឯឈើ2មិនឈើដាក់2ក្នុង block memory มัน2 second 1 đọc 1
okច្រឡំវាសេមួយគ្នាខ្ញុំដឹងមួយណាហើយវិញហ្នឹងចឹងណា2ស្លាប4នេះខ្ញុំមើលនេះ2ស្លាប4អូខេចឹងសុខៃកុមាររតនានៅនឹងសិនខ្ញុំអ្នកប្រាប់ធ្វើជាអ្នកគិតលេខអូខេចឹងឥឡូវយើងសំណួររបស់យើងគឺថាពេលយើង copy block នេះ8ដល់15នេះយើង copy ចូលក្នុង set មួយណាសំណួររបស់យើងណាអញ្ចឹងអ្វីដែលយើងអាចរកបានគឺថាម៉េចយើង convert អាលេខ8របស់យើងហ្នឹងទៅជា binary សិនអញ្ចឹងប្រាប់ខ្ញុំ binary 8ទៅ binary ប្រមាណខៃ8 decimal 8 decimal
1000លោកគ្រូ
1000ចឹងមែន
បាទ
អូខេខ្ញុំអត់បានគិតខ្ញុំគិតសរសេរតាមសរសេរខុសគិតខុសយើងហ្នឹងហើយអូខេបន្តមកទៀតយើងឃើញបាន4 bit ត្រូវនេះ0 3ដង1មាន4 bit ដែរប៉ុន្តែយើងត្រូវការ convert វាទៅជា14 bit វាទៅការ14 bit អញ្ចឹងយើងធ្វើមិនបាន14 bit ហើយ
យើងថែម0ពីមុខ10លោកគ្រូ
ថែម0 10ដងណា0 1 2 3 4 5 6 7 8 9 10អូខេថែម0 10ដងបាន14 bit ហើយបន្តមកទៀតយើងសួរថាក្នុងចំណោម14 bit ហ្នឹង14 bit នេះប្រមាណ bit ជា offset ប្រមាណ bit ជា set ប្រមាណ bit ជា take មើលពីលើនេះប្រមាណ
3 bit
3 bit
ក្រោយ
offset
នោះជា word
ជា word អូខេហើយ word ក៏បានហើយ offset បានអូខេអញ្ចឹងខ្ញុំថែម space មើលឃើញច្បាស់បន្តិចហើយ set យើងមានប៉ុន្មាន set
មាន01 2 bit លោក
អូខេ01គឺ2 bit អូខេហើយអាខាងមុខនេះស្អីគេ
អាហ្នឹង take លោកគ្រូ
អូខេ take អញ្ចឹងយើងចេញមកប៉ុណ្្នេះមកយើងដឹងថា3 bit ខាងចុងនេះគឺសម្គាល់ offset មួយនៅក្នុង log ត្រូវអត់ right ហើយ01នេះគឺសម្គាល់ set អូខេហើយខាងមុខនេះគឺសម្គាល់ take ដើម្បី compare search អូខេអញ្ចឹងបើយើងចង់ដឹងថាតើ data របស់យើងនេះអាត្រេ8ស្ថិតនៅក្នុង set មួយណាយើងមើលកន្លែងណាឡើយយើងមើលកន្លែងណាយើងមើលអានេះយើងមើលអានេះឬក៏យើងមើលមួយនេះហើយ
ដូចជានៅក្នុង set ឯលោកគ្រូ
set នេះមើលនេះអញ្ចឹងអញ្ចឹង convert វាមកជា decimal វិញមក01ស្មើលេខបាន
01ស្មើលេខ1
អញ្ចឹងមានន័យថាអាស្រ័យលើព័ត៌មានហ្នឹងយើងអាចនិយាយបានថាអត្តលេខ8គឺស្ថិតនៅក្នុង set លេខ1បងអត់អត្តលេខ8ស្ថិតនៅក្នុង set លេខ1ទេហើយចាប់នឹងតន់ហើយ
បាទលោកគ្រូស្ថិតនៅលេខ1
ក្នុង set លេខ1អូខេហើយយើងដឹងទៀតថាdata អាលេខ8ហ្នឹងវាស្ថិតនៅក្នុង block រួមគ្នាជាមួយនឹងអត្តលេខ9រហូតដល់អត្តលេខ15អូខេ8ហ្នឹងស្ថិតនៅក្នុង block រួមគ្នាជាមួយនឹង9រហូតដល់15ដូច្នេះពេលយើង copy data ចេញពី main memory ចូលទៅក្នុង cache គឺយើង copy ទាំងអស់គឺមានថាយើងអាចនិយាយម្យ៉ាងទេបានថាអត្តលេខ9រហូតដល់អត្តលេខ15គឺស្ថិតនៅក្នុង set លេខ1ដូចគ្នាតោះណាខ្ញុំពី transition ហើយអាហ្នឹងគឺ set យល់ទេចឹងពេលយើង copy មកអានេះដោយសារនេះ set លេខ0 set របស់យើងចាប់តាមពីលេខ0មកលេខ0លេខ1លេខ2លេខ3អញ្ចឹងមានថាយើងត្រូវ copy address លេខ8លេខ9លេខ10លេខ10 11ដល់15ចូលទៅក្នុងអញ្ចឹងខ្ញុំសុខចិត្តលុបលេខចោលវិញកុំឲ្យច្រឡំព្រោះនេះជា index ណាអានេះជា index ទេ chia data từ một cho với dẫn. Ok, con lấy lên mình mối phí khỏi 4 5 mối chỉnh phó lấy chỉnh hỏi. Ok, ừ. Hey, làm thật. Lục để chào mình. Thành ra như họ pixel mà việc nhận nhóm cụ nói gì một trong định đó. Ok, hay bạn cũ với zone nên có lịch zone đấy. Ok, chẳng address zone đo bấm pass zone đo bấm pass hay bây giờ copy đi bấm bảy chỗ cứ dân copy chỗ con set lịch mũi đại dương ban gì khi mà nhận set lịch mũi chẳng con set lịch mũi như anh đã block của nhà các bạn đấy sân ba block pin internet lịch nếu như hợp block của nhà các bạn đấy free team bạn đi nó bấm bảy bấm 4 dot tập mũi p tập bay tập 4 tập răng. Ok, tất trong sự nổ bí ở trong mấy khu detail những của bạn thì sao bây giờ cái còn trong đơn chùm đồ này ra chỗ và tại bớt cái số tha ta data trong khối như cái này như rằng lúc bây giờ nó hỏi trên mà bán phải thôi đi nhầm rồi để ta bên trong ở dương vô nó trên mình cụ cho bạn chừng nào. Ok, chân okay, so the address number 8 is missed. We cannot find it. But if we access the next address, which is number 9 to number 15, it could be hit, right? Because we already copy the data from address number 8 to 15 in the previous request. Got it? So number 8 is missed, and then we copy it to the set number 1. Then if you make the next request, which is number 9 to number 15, so we are now sure that the data is inside the set here, right? So 9 to 15 is hit. And the same thing for address number 16, because the 16 is located inside another block. So we know that it will be missed again, because when we copy in the previous request, we copy only the block which contain data at address H to address 15, right? So we do the same thing. We copy here from address 16 to address 7 là 23 nhé. 23. Okay. To touch here, touch, and then set. Which set is it? Anyone know? Which set is this one? Okay, you can follow what we have done here. Something. So here from address 16 to 23, going to copy in set number 2. Okay, that's because I already calculated. That's why I know. And if you want to confirm to make sure, you can do just like what I have done here. Okay, so we are copied to set number 2. So set number 2 is here, which means is the number 16 here, 17, 18, 19, 20, 21, 22, and 23. Okay, so we copy the entire block into set number 2. So the next request, which is address 17 to 23, hit, right? Okay. And then we do the same thing here. This one should be the address 24. And then it means as well, we copy the entire block, which is 24, to the 31. It will catch, and it should be in set number 3. Okay. So the address 24 to 31 here, hit. All right. And then again, let's just finish this. Take some time, but we are sure that we understand. The 32 means again 32 here to which number, which is 39. And copy to catch again, and this one, it should be reset, is it? Because we only have 4 steps, and we have set 0, 1, 2, 3. So if you check it again, it copy to set 0 and try to test it out. So 32 to 39 here, it copy to set 0, but set 0, okay, set 0 we don't have it yet. And 32, wait, 32, 33, 34, 35, one should be 24, 25, 26, 7, 8, 9, 31. Okay, and then the address 33 to 39 are hit. Okay. And then the address next should be 40. 40 is missed. Okay, so we copy the entire block, which is 40 to 47. A copy to set number 1. Okay, and here, because we have 2 ways set associative, meaning that in one set there are 2 blocks. So as the block 0 is occupied, you can use the next block here. All right. So here we have 40, 41, 42, 43, 44, 45, 46, and 47 here. Okay. So address 42 or 41 until 47 is a hit. 41 until 47 hit. Okay. And it's almost done because our loop is only until 51 here. Okay. So after that, address 48 a miss, and then we copy the entire block again. 48 until which one? 51. Actually, it's not 51, but 48, 7, 8, 56, 55. Okay, 55. Copy to set number 2. Like this. Two, 1, 2, 3, 4, 55. Okay. Now actually, the CPU may request only up until here. Only. The remaining here we don't access because remember, CPU may request until 51 only. So here's meaning that we are accessing only to 51. So here 49, and here 51. Okay. So here is the first loop, and in the second and third loop, it is easy because we are not replacing any content. If in case you are replacing the content inside here, that will become more complicated. But because we are not replacing anything at all, you see the number 8 to 15, 16 to 23. In short, the data from 8 to 51 are exist in our category. So we are sure that in second and third loop, from 8 to 51 are all hit. Okay. This is the second loop. And this is the third loop.
Hello, teacher.
Yes.
Yes. Can you show me when change block I calculate is how to know to where set to go, where set to continue.
និយាយជាខ្មែរសួរខ្ញុំដងទៀតបាន
Chờ xong xua nó về change block nó về là kẻ này mấy tới bạn đăng tham viên nó set tí muối nó về là những thơ tới việc trong set tí muối
ចំសិតទីមួយចំសិតទីម៉ានទៀត
ខ្ញុំឃើញមកចំលេខ5
ចំលេខ5តែនិយាយនេះមែនអានេះមែនអានោះមែន
បាទនៅក្នុង block មួយនៅពេលកន្លែងដូរ block ណា
ឥឡូវសួរកន្លែងនេះមែនលើកអត់ត្រេះមួយចំមួយមកលេខ8ហ្នឹងមែន
អត់លេខ8លេខ40ឆា
លេខ40
40 yes
ដោយសារនេះខ្ញុំអត់បានគិតនេះទេខ្ញុំយកមកស្មានយកនេះថាវាលេខវាត្រូវ order អញ្ចឹងតែឥឡូវយើងសាកល្បងលេខ40អញ្ចឹងអូខេឥឡូវសាកល្បងលេខ40ខ្ញុំខ្ញុំតិច
មួយទៀតចាសិស្ស exchange គាត់ថាមកកុំព្យូទ័រ teacher គាត់អត់ទៅ require រៀនទេខ្ញុំជឿអញនិយាយខ្មែរបង
តាមពិតខ្ញុំដឹងរឿងហ្នឹងតើតែដោយសារតែខ្ញុំថានិយាយខ្មែរប៉ុន្តែថាបើអង់គ្លេសហើយ start អង់គ្លេសទៅអញ្ចឹងខ្ញុំក៏អង់គ្លេសសុទ្ធដែរទៅ
តែពេលឆើនិយាយអង់គ្លេសកន្លែងខ្លះស្ដាប់អត់សូវបានឆើអត់យល់
អញ្ចឹងសួរបញ្ជាក់មកថាកន្លែងណាដែលត្រូវខ្ញុំនិយាយភាសាខ្មែរឡើងវិញណាតាមពិតខ្ញុំក៏ចង់និយាយខ្មែរដែរវាស្រួលនិយាយផងតែដោយសារខាងសាលាអ្នកបត់ថាឲ្យខ្ញុំនិយាយអង់គ្លេសអូខេអញ្ចឹងឥឡូវចាំឥឡូវយើងពេកដែរ
មួយទៀតឆើទៅពេលដែលនេះសុំ meeting លើក្រោយឆើអាចដាក់ជា schedule meeting ឬក៏នៅពេលដែល join team គ្នាយើងភាគច្រើនគាត់អត់ឃើញ team join ឆើ
អត់ឃើញ team join បាទខ្ញុំបង្កើត meeting នេះអត់ឃើញកន្លែង join មែន
បាទអត់ឃើញកន្លែង join ហ្មងលើក្រោយនៅពេលដែល meeting ឆើដាក់ schedule meeting អញ្ចឹងណាដល់ពេលហើយបានស្រួល join អញ្ចឹងហើយពេលខ្លះពេល join ហើយចូល vetting ទៀតតាំងពីអាទិត្យមុនមកប្រហែលផ្សេងដូចអត់ឃើញអីម៉ោងឆើមួយគឺបាក់ជាប់ដល់ invite
អូខេ sure អត់ដឹងថាវាអត់ join ពោះអូខេ come back here លេខ40ណាអញ្ចឹងយើងធ្វើដោយលេខ8នេះដែរខ្ញុំ copy នេះមក3ចេះស្តង់លេខដូរទៅជា40 40 convert វាទៅជា binary អូខេខ្ញុំ convert ទៅជា binary កាត់ចូលរបស់យើងអត់ដែរ40 convert 10 copy ពីនេះមកបានហ្នឹង0អូខេហើយបន្ទាប់មកគឺរូបមន្តយើងចាស់3 bit ខាងចុងគឺសម្រាប់Word តកវាច្រើនតិចហើយបន្ទាប់មកប្រហែល2 bit បន្ទាប់គឺសម្រាប់ set ហើយខាងមុខយើងត្រូវថែម0ឲ្យគ្រប់14 bit 14ដែរចាំនេះយើងមានបាន2 4 5 6អញ្ចឹងថែម0 0 10 11 12 13 14អូខេគ្រាន់តែមើលលេខនេះដឹងបាត់អីលេខ5ពីណាមកមិន01នេះមើលត្រូវអត់01ស្មើ set 1មិនចឹង
បាទខ្ញុំគិតច្រឡំ
ពេលយើងបូកថែមមួយនេះទៀតដឹងនេះ ចឹងធ្វើម៉េច convert វាចឹងមកព្រោះថា order របស់វាតែងតែបន្តគ្នាចឹងដោយសារខ្ញុំបានគិតខ្ញុំរាប់យកមក1 2 3 1 2 3 0 អូខេចឹងហួចឡើងលើតិចនេះចឹងខាងលើនេះគឺលុបទី1អានេះលុបទី2នេះលុបទី3បងលុបគូពីក្រៅទេចឹងអានេះលុបទី1ណាអានេះលុបទី1ម្ដងពី8រហូតដល់51អានេះលុបទី2នេះលុបទី3អូខេចឹងយើងអាចរាប់មកថាចំនួន hit ប្រមាណចំនួន miss ប្រមាណនេះ851មានប្រមាណ132ចែកជា3ខកមើល hit ប្រមាណ44 44 88អានេះយើង miss 1 2និយាយទៅដកតា miss ប្រហែលចេញនេះ1 2 3 4 5 6អញ្ចឹងយើងមាន6 miss ក្នុងចំណោម132អូខេអញ្ចឹងបើយើងចង់បានចំនួន hit វិញគឺ126ហើយជួយគិតគ្នាតែដូចខ្ញុំគិតខុស126ចឹងយើងចែកមក126ចែកនឹង132គឺស្មើនឹង95.45%យើងគិតជាភាគរយបើយើងគិតលេខក្បៀសគឺ 0.9545 អញ្ចឹងខ្ញុំគិតជាភាគរយវាទៅជា 95.45%តោះនេះភាគរយស្រួលហេតុតែចូល
បាទឆើមិន126ហ្នឹងបានមកពីណាឆើមិនមើលអត់តាន់
126គឺយើងចំនួនសរុបចំនួន126គឺចំនួន hit ទាំងអស់ហើយខ្ញុំធ្វើនេះបាន126គឺខ្ញុំយកអាមីសមកដកខ្ញុំរាប់នេះគឺមីស1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 86 87 88 89 90 91 92 93 94 95 96 97 98 99 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 100 4 5 6 ហើយនេះ6ដងក្នុងចំណោម132 request អញ្ចឹងយើង132ដក6ចោលទៅមិនសម126អញ្ចឹងយើងក្នុងចំណោម132 request យើងមាន126 request ដែលរកឃើញលោក data នឹងឃើញអញ្ចឹង hit ratio គឺយើងត្រូវហៅចំនួនដែល access ទាំងអស់ហ្នឹងដែល hit ចែកនឹងចំនួនសរុបអញ្ចឹង126ចែកនឹង132គឺយើងទទួលបាន 95.45%អូខេអញ្ចឹងតាមពិតសំណួរ B គឺចង់បានលេខនេះទេណាហើយអានេះយើងអាចគិតមកខ្លួនឯងបាទយើងអាចដាក់ក្នុងនេះទៅស្រួលគិតទេអានេះណាតែបើសិនបើគេសួរចេះវិញថាបន្ទាប់ពីយើងធ្វើ loop 3 ដងពីអត្រាទី8ដល់អត្រាទី51តើនៅក្នុងខាច់របស់យើងមានអត្រាគេខ្លះក្នុងករណីហ្នឹងយើងត្រូវគូតារាងនេះចេញមកតារាងនេះក្នុងករណីគេសួរថាក្នុងខាច់វាមានអីនេះខាច់របស់យើងរូបតំណាងខាច់យើងឃើញចាក់ស្ដែងខាច់នៅពេលដែលយើង access loop 3 ដងហ្នឹងមកយើងឃើញតានៅក្នុង block 0 box set មួយគឺពេញទាំងអស់មានdata ប៉ុន្តែនៅក្នុង block ទី1របស់ set ទី0និង set ទី3គឺអត់មាន data ទេអូខេសំណួរនេះវាឆ្វេងឆ្ងាយពីនេះឲ្យ
ឆាយ សុំ send file ហ្នឹងចា
file draw IO ហ្នឹងមែន
បាទចាបាទ
ចាំនឹងផាត់ទី3អាហ្នឹងមិនតាន់ពិបាកតិចទៀតអាខាងក្រោមពិបាកជាងហ្នឹងទៀតតែពិតវាពិបាកហ្នឹងគឺវាថាគោះនឹងច្រើននេះទីធ្វើដល់250នៅអាទី7ទី7នេះគឺអត់អាទី6ដោយសារគណិតហេតុចូលមកវាវិញតិចអាទី7ហ្នឹងគឺស្តៀងជាមួយនឹង 6A ណាទី7ហ្នឹងវាគាត់ថាបដូរពី two way set associative នៅក្នុង node A ទៅជា four way set associative ក្នុង single B អញ្ចឹងអានេះខ្ញុំអត់ធ្វើទេខ្ញុំ skip វាពួកយើងតែខ្ញុំ skip តែពួកយើងគួរធ្វើនៅកន្លែងសរសេរសភៅដាក់ធ្វើនៅផ្ទះខ្លួនឯងទៅហើយបើចង់ជាងចំណោយត្រូវខុសអានឹងអាចផ្ញើខ្ញុំជួយមើលឲ្យបានហើយរមាត់ទី8នេះគឺនៅទៅការ set associative ដែរទេហើយសំណួរ A គឺ two way set associative ហើយសំណួរ B គឺ four way set associative អញ្ចឹង7 8ហ្នឹងគឺដូចគ្នាខុសពីលេខទេហើយសំណួរទី9we have temperature what size 8 bit 9នេះយើងគិតច្រើនតិចតែនេះគឺយើងប្រើ direct map ណាយើងចូលប្រើ direct map ម្ដងអញ្ចឹងក្នុងករណីសំណួរទី9នេះគឺពេលយើងគិតស្តៀងមួយនេះតែ9នេះពិបាកជាងអាលេខ3របស់យើងនេះតែ concept គឺស្តៀងគ្នាអូខេហើយ9នេះធ្វើយ៉ាងយូរអាហ្នឹងអាចចាំជួបនៅលើក្រោយធ្វើ1 2ទៀតបានទេព្រោះផ្សេងស្តៀងគ្នាដែរដល់ខាងក្នុងនេះចាក់ទៅមួយ virtual memory បងចឹងអា9នេះចាំយើងធ្វើជួបគ្នាលើក្រោយយើងធ្វើអាប៉ាល់9នេះហើយអា7 8 learn ខ្ញុំពួកយើងយកខ្លួនឯងណា7 8ធ្វើខ្លួនឯងបាន6យើងកាយហើយអា4 5នេះក៏ធ្វើខ្លួនឯងបានដែរគឺរៀនគ្នាជាមួយបាត់ទី3វិញដែរអញ្ចឹងទូយ៉ាងណាដល់មកហើយ250ធ្វើមួយទៀតអត់តាន់ទេខ្ញុំចាំឆ្លើយសំណួរនេះវិញតើការមានអីសួរមើលយល់អីអាចសួរតកតងនឹងផាត់នេះបានខ្ញុំផ្ញើបានហើយsize 3 1មុននេះ9 10 ដល់36អត់មានសំណួរសួរទេស្ងាត់ចឹងណាចូល project internet programming ហ្នឹងមិនវិញមានបញ្ហាអីឥឡូវហើយចាប់ប្រើបានទៅត្រូវមានអីចាក់អីទៀតទេជាច្បាស់គ្រប់គ្នាណាហើយពេញនៅក្នុងtask list ហ្នឹងទៅក្នុង Excel ហ្នឹងទៅ ដើម្បីយើងសួរមើលកុំផ្ញើមក Telegram ណាផ្ញើជាថៃវាពិបាកមើលផ្ញើនៅក្នុងនោះទៅខ្ញុំដឹងថាយើងត្រូវ order ផង order subtask ហ្នឹងបើ feature មួយណាប៉ុន្តែយើងឃើញគ្នាយើងខ្លះផ្ញើមកដូចមាន8 9នេះតិចហ្នឹងនឹងថែមមកហើយទៅព្រោះពេល3ខែយើងធ្វើទូចមួយមិនសមថាម្នាក់ធ្វើ login form មួយហ្នឹងធ្វើ3ខែវាអត់ស្កអត់សល់ណាចាហើយហ្នឹងមានsubtask 3អីចឹងទៅអាហ្នឹងគ្រប់គ្រាន់សម្រាប់3ខែហ្នឹងដែរចឹងព្រោះឃើញតិចពេកថែមមកហើយទៅបើសិនបើអត់មានសំណួរអីត្រូវសួរទេថ្ងៃហ្នឹងយើងបញ្ចប់ប៉ុណ្ណឹងហើយអាទិត្យក្រោយយើងធ្វើលំហាត់1 ឬក៏2ទៀតហើយនឹងចូលមេរៀនបន្ត